I know it's been a while since we've graphed piecewise functions, but I'm hoping that just with a little bit of effort here that it'll all come back to you. -9 to -5, that's our first domain restriction. So I'm going to count over 2, 3, 4, 5, that's -5, 6, 7, 8, 9, that's -9. So that's our first domain, like I said, restriction. 1, 2, 3, yeah. And I'm going to go ahead and highlight that. So if you remember, we highlighted our domain restrictions. That's our first domain restriction. And then let's highlight our next one, -5 to 0. So -5 to 0, we'll put that in orange. And then 0 to 4, we'll put that in, let me put a count here, 1, 2, 3, 4. So there's 4. And we already used orange, so let's use pink here. So there's our 0 to 4. And then 4 to infinity, x is greater than 4. We're going to go ahead and highlight that in yellow. I forgot to do this one here. So starting with the first function, y equals absolute value of x plus 6 minus 3. So we know that the absolute value functions look like that. The vertex is normally at 0, 0, but on this vertex we're going to go left 6 and down 3. Left 6 and down, gosh, where is it? 1, 2, 3. There's the vertex of the absolute value. Now again, absolute values go up from left to right. From the vertex there, we go up to the right, and we go up here also like that. And when x is equal to -9, that's going to be a 3 minus 3, that's 0. So if we follow the slope, you go up 1 and over 1, up 1 and over 1, and then we end up there at -9, 0, and we end up here at -5, -2. So if you were to replace x with -5, the end point of the interval, -5 plus 6, and then you subtract 3. -5 plus 6 is 1. 1 minus 3 is -2. You'd have the coordinates of this hole right here, and the hole because that's a less than. And it's this closed circle because that's x is greater than or equal to -9. And then for the orange region, we have the y values are 3. So 1, 2, 3 in the orange. And it includes both the endpoints. So 1, 2, 3 there. 1, 2, 3 there, and everything in between. Connect the dots. That takes care of the orange region. The pink region, 2x minus 3. We have a y-intercept of 1, 2, 3, but there's an open circle there. Because of that, x greater than 0. And we have an up, let's see, we're going to go all the way from 0 to 4. So we go up 2 and over 1. The slope is 2. Up 2 and over 1, 2 over 1, 2 over 1, and then up 2 and over 1, and we have an endpoint right there. Now, let's go ahead and replace x with 4 so we can see where the y value is, just to make sure we counted correctly. 8 minus 3 is 5. So the 1, 2, 3, 4, 5, 4, 5 is where that line ends. This line segment, I should say, this part. So that's linear, right, like that. And then we have x minus 5 cubed, sorry, not cubed, squared minus 3. And so that has a vertex of 5, -3. 5, 1, 2, 3. There's a vertex. And we have to figure out, well, when x is equal to 4, what's going to be the y value? So we're going to plug 4 in. I know that x is not allowed to equal 4. We're going to have an open circle wherever this goes. -1 squared is 1. 1 minus 3 is -2. So 4, -2 then, we have an open circle, and then we have this curve, and the graph looks just like that. So that, in a nutshell, is about how fast you can do that. And I took my time, but what we had done in the past, just to reiterate, we've drawn, if we do it kind of like basic, first time doing it, we draw that graph, left 6, down 3, and we draw the whole function. We draw the whole graph. And then we highlight the blue region, and we're like, okay, we're only allowed this graph in the blue region, so anything to the left of the blue region we have to erase, anything to the right of the blue region we have to erase. And we just repeat that for every one of these graphs. You should know how to draw the graph of an absolute value function, constant, linear, and quadratic. And if I threw a cubic one in there, you should be able to do that as well. So that's that.